Okay, I get 8.7 milliammeter. Okay, and the brightness are the same, but be careful. Look, before using this bullet, this one, okay, so I cut this light, this wire, so I have only one light bulb in my circuit. If I simulate, look at the value of the current, the indication of ammeter, I have 4.35 milliamps. Okay, this is the value. But if I add another light bulb in parallel, the current becomes great. The current is the double of the current I have when using only one light bulb. Okay, see it like this. I make the connection. I make this also the connection. Instead of 4.35, look at this. If I make this, I have 8.7 milliamp, really the double of the current I have when using only one light bulb. So you see the brightness is still the same. So I will use another bulb, another light bulb. Okay, I turn it, so it will be the third one, always in parallel, and you will see what the difference. There will be no difference. So you see all the other difference. So this is the third. Okay, this is the third, my third light. This is the second one. Now I just make the correction between this and this one, and then the connection between this and this one. So I have 3 branches in my circuit: the first branch, the second branch, and then the third branch. The current that flow through until this point will be divided by 2. One part flow through this branch, the other part flow through this side until this point. This one also will be divided by 2. One flow through this side, and then the other flow through a light tree. Okay, and all currents are going to flow through this ammeter. So the main current that flow through this side will be the same that flow through this side. Let's simulate our circuit to see what's gonna happen. Okay, you see, so the voltage rate here at the level of the power supply is the same at the level of all the lights. This type of connection is what you have in your house. When using your computer, you can also use your TV, you can also use your video player, you can also use any kind of apparatus you have in your kitchen that you don't get any series apparatus connection in series in your house. But what you have generally using light or radio, TV, PlayStation, or any kind of electric or electronic devices you have, it's a parallel combination. Okay, it's parallel using. So these are all connected in parallel. You have 3, 4, 5, or even 7 lamps or lights bulb connected in parallel, and the voltage here are the same. So this is very important. But now look, I'm going to use my voltmeter. I put my voltmeter here for I can measure the voltage, the volt drop of this ammeter. Look, okay, so I make the connection between this side until this side. Okay, and then I make the connection between this side and this point. Okay, so let's simulate. So see, this is 230 volt, exactly the potential drop of my power supply. I have 230 volt. That's the voltage here I have here. So it's the same here, and then the same I have here also. So, okay, So this type of application is very simple. It's a free application. You can use it everywhere in Africa, at Accra, at Addis Ababa, Lagos, at Lomé, at Abidjan, Ivory Coast, and Cameroon. It's very important to use such application for the student can simulate many kind of physics application to improve, to really understand their lesson, and then to make them to become evidence. This is important. If you can't do it, you as teacher, you can ask the help of your colleague, or a technical pedagogical team must be available to help you to use this application to integrate ICT in your physics teaching in Africa. Thank you.